You won't believe this, a tiny welding machine born from a single spark plug. Yeah, that's right. What started as just a small experiment turned into a surprisingly powerful mini welder that can handle real metal work. And the best part? It all began from one simple idea: can a spark plug actually weld? Today I'm going to show you how that crazy question turned into this compact, functional welding machine. First, we'll start by making a simple short connection using this piece of wire. One end of the wire goes right here, to the threaded tip of the spark plug. The other end? That's going straight to the metal body of the plug. This little step is what brings the whole setup to life. It's where the current starts to flow and the magic begins. You probably already know this. Short-circuiting isn't just linking two points with a wire. It's one of the first principles that taught us how to control electricity. In the 1800s, great minds like Faraday, Edison, and Tesla uncovered the hidden logic of current flow, realizing that electricity doesn't just move, it seeks balance. When two conductors are bridged, electrons don't wander. They race, chasing the shortest path shaped by potential difference. That idea, what we now call a short circuit, began from curiosity, not caution. Early engineers shorted generators and coils just to see how much power could be unleashed in a heartbeat. Those bright blue arcs were the ancestors of spark plugs, arc lamps, and the first welders. Every modern spark carries a trace of that same discovery, turning danger into understanding. Now, when we short this spark plug with a copper wire, we're not just connecting metal to metal. One end attaches to the threaded tip, the ignition heart. The other connects to the metal casing, the ground. In that moment, the plug becomes a tiny plasma chamber. The current leaps across the air gap, ionizes it, and forms plasma, the fourth state of matter. That's not just a spark. It's a controlled stream of energy hot enough to melt metal, the same focused arc that powers a TIG welder, just smaller and smarter. So when that little flash appears, remember, it carries over a century of innovation. From Faraday's coils to Tesla's arcs, the tools may change, but the essence remains, harnessing chaos, shaping it into creation. Here I've prepared a wooden handle, just the right size for a firm, comfortable grip on our homemade welder. Wood works perfectly, it's non-conductive, light, and easy to shape. And now we'll drill a hole deep and wide enough to fit the threaded body of the spark plug snugly inside. Keep it tight but not forced, secure yet gentle on the wood. This quick step turns random parts into something that actually feels like a real welding tool. I'm holding a simple single-core wire here. We'll connect one end, it doesn't matter which, to the ground terminal of the spark plug. The other end? We attach a crocodile clip, which will connect to the positive terminal of our power source. This step is essential. It completes the circuit, allowing current to flow through the plug and generate our first controlled spark. This is the crocodile clip we'll be using. Its spring-loaded jaws make it easy to attach securely to any terminal, and it ensures a solid connection without slipping. Once all the connections are secure, it's time to move on to the next step, shaping the welding tip. The goal here is to make the welding tip from the core of this AA battery. We'll start with the first step, removing the outer casing. Carefully strip away the metal shell and insulation to expose the inner core. Once that's done, we can extract the core itself, the conductive material that will become our welding tip. This core is ideal because it's compact, conductive, and easy to shape for precise welding. Once the battery core is removed, we'll give it a quick cleaning. Wipe off any residue or conductive powder sticking to the surface. To shape a proper welding tip, we'll sharpen one end of the battery core. The pointed end concentrates the electric arc, allowing precise and stable sparks for welding. After sharpening, we'll attach this welding tip to the spark plug's terminal. Make sure it fits snugly. A secure connection ensures efficient current flow and stable sparks during welding. Of course, if we already have a connection to the negative side of the current, we also need a corresponding tool for the positive side. We'll make another wire with crocodile clips on both ends. This will connect to the negative terminal of the power source, completing the circuit for our mini welder. Here, I'm using a small battery with a suitable power rating to supply our homemade welder. It's compact, easy to handle, and provides enough current to create a stable arc without overwhelming the components. Choosing the right power source is crucial. Too weak and the spark won't form. Too strong and you risk damaging the setup. And of course, we can't expect this homemade device to match professional tools you'd buy in a store. So we'll stick to a few small test examples. Now let's enjoy the process and see our mini welder in action. Alright, that brings us to the end of our video. Today we saw how a simple spark plug, a few wires, and even a battery core can come together to create a functional mini welder. Remember, the journey here isn't just about making sparks. It's about understanding the principles behind electricity, current, and how creativity can transform ordinary items into useful tools. Thanks for watching and keep experimenting safely.